in today's class we'll be going with the next scheduling algorithm, primitive scheduling algorithm, that is called as a priority scheduling, right? In the earlier class we have engaged the class for the FCFS, primitive scheduling algorithm, and the shortest job first. Okay. In today's class we'll be going with this priority scheduling algorithm. So before to that, let us go some brief introduction. So what exactly this priority scheduling algorithm does, right? So we have gone with respect to a non-primitive cases. There, what is that case? What is the funda of the non-primitive cases? Non-primitive priority scheduling, depending upon the priority or the preference given for the each and every process, that particular process is given a chance first for the execution, to enter into the CPU for execution. Depending upon that, it was done in case of non-primitive. What is that main difference? I told you the difference between non-primitive and the primitive is that when the non-primitive, I am going to repeat it once again. So non-primitive and primitive difference is, so whenever we are solving with respect to a non-primitive, there is no interruption of any of the process, right? There is no disturbance of any of the process once it is entered into the CPU for execution. Until and unless its burst time gets completed, it's not supposed to allow for the other process, right? This is in case of non-primitive. Whereas in case of your primitive cases, how it happens here, there is an interference, there is a disturbance occurs in the process, therefore we are applying the context switch, that is changing of the process from one process into the another process, right? That is what the preemption is being added. So that is the main difference. And here we will be not having an arrival time here, right? Whereas in case of primitive, the arrival time is considered, right? So now let us begin with this priority. The first point, a priority is simply can be termed as it is an integer number, right? It is a number. This is a priority column. What we are finding it is just an integer number which is associated with each and every process, right? That is what the first point. It is an integer number which is associated with each and every process to execute into the CPU, right? And the main another important point we can say that how the priority we can say normally the priority will be considering like lower the number, highest the priority. It means that if I say there is some process P1, P2, P3 and the priority is set like 0, 1, 2. It means that lower the number means 0 will be the highest priority and highest number will be the lowest priority, right? This is lower the number, highest the priority. Fine. If I simply say it as like this, lower the number will be 1, that will be the highest, and higher the number will be the lowest. Means which number will be given a first chance? Means obviously P2 will be given a first chance. And this we are going to consider with this arrival time of the process and what time of this process has entered and what is the priority it was given. In that fashion, we are first going to prepare a ready queue state, right? We are first going to prepare a ready queue. It means that how the process is entered into that, it will be put into this ready queue. Fine. After this, one process will be given a chance to enter into CPU for execution, right? In that fashion, first we are going to prepare a ready queue also here. Note this point. And the main disadvantage of using the priority is called as starvation. I have written the main disadvantage of using the priority scheduling is it leads to starvation. Now, what is the meaning of starvation here? Starvation is nothing but any process which is there into the waiting queue or in a ready queue for a longer period of time. Okay, any process which is there into this ready queue state for a longer period of time to get its chance to enter into the CPU, and sometimes there will be a chance that it may not get into CPU for execution at all. It means that it will be simply keep on waiting. That's why it is a wastage of space or time. That's what we term it as a starvation. Got the meaning? Any process which is there into this ready queue for the longer period of time to waiting for its chance to enter into the CPU, that process we term it as starvation, right? And to overcome this problem, that's what the last point I have written, to overcome the problem of this starvation, though the process which is there in the waiting queue for longer time, it will will not get, or sometimes it may get, but it has to stay into this ready queue state, right? How to solve or how to overcome that problem, there is a separate technique to overcome that problem called as aging. Okay, what is that aging? Aging is simply nothing but it is basically used to increase the task of the priority. Okay, which is waiting for a longer period is starvation. To increase the priority time itself, task of the priority, task is nothing but the process. I told in the beginning of the class, task, process, job, all these things are one and the same. To increase the priority time of it, if we increase the priority time, obviously there will be no chance of staying into this, right? Time, if we are not at all increasing it, it will be not getting quickly or easily, you will be not getting that process into the CPU for execution. To get this chance, simply we are increasing the time of that process. Okay, to overcome that starvation problem, which technique we are using? Aging technique. Is that clear? Fine. Now let us consider solve this primitive scheduling with the help of this example here. How many processes we have mentioned here? 4 processes. For P1, P2, P3 and P4. And the arrival time of each and every process has been mentioned 0, 2, 3 and 5. And priority is given and followed by a burst time. Right? So normally in the earlier program I told you in non-primitive cases just process, priority and a burst time. There was not an arrival time was not mentioned. Right? So at that time simply, though for time being you just forget this column. Right? According to this, which process will be executing? Tell me. First will be given a chance for P3 because the priority of that process is given. Lower the number, highest the priority. Lower number, this will be, for example, let us consider 0 is highest here and highest number will be the lowest. Means this will be getting last chance for execution, whereas this is given a first process for execution, right? So this is how. Means first P3 will be given a chance to execute, then after that P2 will be given, then P1, then finally we will be going for P4. This is clearly known by looking into the example, right? And this we are going to consider with respect to the arrival time plus priority, right? In similar way, we are going to prepare a Gantt chart here. Now, look into the Gantt chart. At this process, at the 0th time, beginning of the process is always considered to be a 0. At the beginning, always this will be at the 0th arrival time. Which process has entered 0th arrival time? Which process has entered P1, right? Therefore, we are going to put into this CPU first timing as 1. Okay, so at 0th millisecond, the process P1, it is being given, right? And it is going to execute it for how much more possible. So according to our Gantt chart, now the arrival time of the process P1 has begun at 0. So P2 has entered into the ready queue first, right? And the priority of that is 2. We cannot give that priority process to enter into the CPU for execution because our first priority is at P3. But arrival time here is at 3 times. It means that till that this arrival time comes, the remaining above process has to be in the ready queue itself, right? For example, I will be preparing a ready queue here. How will be my ready queue? First, at 0th arrival time, P1 has entered, right? It is going to stay for 2 milliseconds of time. Once it reaches 2 milliseconds of time, checking the arrival time, yes, at 2 milliseconds of time, another process has entered. Let us write simply it as P2. Now check what is the burst time of the, what is the priority for P1? 2. And what is the priority of this P2? 1. Can we compare here? If we can compare, but the priority we cannot give it because the first preference would be as a lowest number, right? Here the third process is given first, therefore they are not allowing the P1 and P2 to enter into the CPU for executions. Therefore it will be there continuing until and unless the first preference or the first priority for which process we have given, that is B. Until it arrives to that point, remaining process keeps changing to that, right? Therefore, P2 is given as this has to run for 1 unit amount of time. So 2 plus 1 will be 3, right? So 3 milliseconds. And after that 3 milliseconds, check again in the arrival time at 3 milliseconds, does any processes enter? Yes. At the arrival time 3, which processes enter? 3. And now at the corresponding check, the priority is 0. Now our concept is clear because according to priority algorithm, which is having a first preference, that process is given a chance. Now what we do, simply the P3 is there. Now this process will be removed from the CPU and this is given a chance to enter into the CPU for execution, right? This is our first priority. And what is the burst time? Once the priority is given for this, now we are going to check what? Burst time. What is the burst time? 2 milliseconds. Therefore, right now, 2. What is earlier? 3 plus 2 will be 5 milliseconds. Got it now? After this, now P3 has completed its task. We need not have to bother about it. Now, which after 5 milliseconds, it has taken 5 milliseconds of time, right? Now check whether 5 milliseconds of time of the arrival of any other process has entered. Yes, entered. 5 milliseconds of time in the arrival time. Check out. It has entered in the 5 arrival time. Which process has entered? P4. Obviously, we are going to give a chance for P4 here, right? P2 and ready queue. I have to prepare a ready queue and parallel branch. And P4. Now, what is the P4 priority? Third position. It means it is having a later priority compared to that of P1 and P2. Now you can easily guess P1, P2 and P4. Though the P3 has completed a task, so you should not consider that. P1 is having priority 2, P2 is having priority 1 and P4 is having priority 3. Means among this, which is given the next chance for execution? P2. Obviously P2 because it has set the priority 1. Therefore what we do here, we are going to give a chance for P2 to enter into the execution. Therefore, simply remove from ready queue from P2 and allow the CPU to enter into execution. Got this meaning now? Therefore P2. And what is the burst time of the P2 over there? 5 milliseconds. 5 milliseconds. Right? Why did I take here it as 4? Because it has entered into this ready queue for how much amount of time? For 1 milliseconds, right? Therefore, 5 minus 1 will be 4, right? In this also, P1, we have run this process into the CPU for 2 milliseconds of time, right? Therefore, 10 minus 2 will be 8. Just for understanding it is period, right? You do not have to write this column, just for reference, right? Therefore, the first time already the P2 has once entered in the beginning by taking 1 milliseconds of time. Therefore, we need to subtract 5 first time minus 1. That is 5 minus 1 will be 4. Therefore, the P2 will be 4 burst time. What is the total of this? 5 plus 4 will be 9. Okay. So after this, the task has completed. 5 the burst time is completed, and P2 as well as P3 has completed. Now, which any other process is there after 9 milliseconds of time? Do we find any arrival of this process after 9 milliseconds? No. Right? You should check after every process has completed its task. At this respective time, we are supposed to check in our arrival time. Does it has encountered? No. 9 after 5, none of the process has entered. At that time, remaining till this time, it is working by preemptive. And from here onwards, it will be simply executing like non-preemptive. It means that until and unless this execution completes, it is not allowed for the next process. That's why it is called as non-preemptive cases. So after P2, definitely we know it. We have completed this P3. We have completed with P1. then definitely which process is given a next chance? P1 is given because the next priority highest will be 2. Therefore, P1 will be given a 2. And what is the first time I told here I have taken it as 8? How did I take 8 seconds? Because first time the P1 has entered and it is taking how much amount of time? 2 milliseconds. Because arrival of the next process was 2. Therefore, 10 minus 2 will be 8. That's why we have written it as 8. Right? 9 plus 8 will be 17. Got it? Right. And the last and the left out process will be how much? Which process? Definitely will be P4. And what is that burst time of that process? They completely the 20 milliseconds. 20 plus 17 will be 37. Right? So this is how our Gantt chart is prepared. Okay. Now we shall go with this next turnaround time and the waiting time. Right? So in yesterday's class, what did we do? What is the turnaround time formula?
Completion time.
Yes. Turnaround time. The formula for this is completion time minus arrival time. Right? Now for that each and every process for P1, P2, P3 and P4. What is the completion time of the P1 process? How much it has taken?
17.
P1 is here, but we have not completed the task. Where did we complete? P1, here it has completed fully. What is that turnaround time for this? Completion time is 17. Minus arrival time. What is the arrival time of the process P1? 0. 17 minus 0 will be 17. P2. Completion time of the P2 is where?
9.
Do we consider this?
No.
Because the first time of the process is completed here. What is that? 9. Therefore, 9 minus, what is the arrival time of the P2? 2. What is this P3? Completion time? 5 milliseconds. What is the arrival time?
3.
P3 will be arrival time is 3. 5 minus 3 will be 2. P4, where did it complete its?
37.
It does 37, right? 37 minus, what is the arrival time of the P4 process will be 5. What is that?
32.
32, right? So after this, what we are supposed to do?
Average.
Turn around time. 17 plus 7 plus 2 plus 32 divided by 4, right? What's the total?
58.
41 plus 7, 58 divided by 4, right? 4 ones are, 4 fours are 16. 14.2 milliseconds. This is how our turnaround time is done. Now similarly, what we are going to do it? Next, waiting time. Waiting time is also calculated using which formula?
Turnaround time minus burst time.
Yes. Waiting time is then calculated using turnaround time minus burst time. Okay. What is the turnaround time for the process P1? 17, right? 17. What is the burst time of that process P1 given in the problem? 10. 17 minus 10 will be 7. P2. What is the turnaround time for P2?
9.
9 is it. It is given in Gantt chart. 9. What is the burst time of that?
5.
Given in the process? 5. 9 minus 5 will be 4. For P3, how much it has taken? 5. Burst time is 2. 5 minus 2 is 3. P4 is, first time turnaround time is 37 minus what is the burst time is 20. 70. Got it? Now find an average of it. How we are going to find? 7 plus 4 plus 3 plus 17 divided by
31.
so 14, 7, 7, 14, 14 plus
31 ma'am.
31 divided by
4.
4. Okay. 4 7 are 28. Okay. 4 7 is 28 plus 3. 7.3.